Here's another example of a quadratic equation. Highest power of the variable is 2. It is an equation. Equal sign tells us that. It's in standard form. And it's missing a term. It's missing the first power term. When you have a quadratic equation that is missing the first power term, it lends itself beautifully to solving it using the square root property. Now let me illustrate for you how you use that square root property to solve an equation like this. What we're going to do is we're going to isolate the x squared. So I need to get rid of the 36 by subtracting 36 from both sides. And I have 4x squared equals negative 36. I want to isolate it completely, so that means I want it to have a coefficient of 1. So I'm going to divide both sides by 4, which gives me x squared equals negative 9. Now, the square root property says this. Anytime you have some quantity being squared equal to a constant, the quantity that was being squared, in this case x is being squared, x is equal to plus or minus the square root of the constant. That's, in effect, the same as we sometimes say you took the square root of both sides. The square root of x squared just gives you x. Square root of negative 9, when you take the square root, you have to consider both the positive and negative root. Oh, but we're now trying to take the square root of a negative number. Do you remember what happens when you try to take the square root of a negative number? You move from the real number system into the complex number system. And in particular, this is going to be the imaginary portion of the complex number system, our imaginary numbers. Remember how we simplify the square root of negative 9? We break it apart into the square root of 9 times the square root of negative 1. And the square root of 9 is 3. And remember, what's the representation for the square root of negative 1? That's lowercase I. So the two solutions to this quadratic equation are imaginary solutions. They are 3i and negative 3i. They are imaginary solutions, which, believe it or not, have some very practical applications, especially in certain areas of the sciences. Physics and modern physics is one place where it's used extensively. So here was an example of using this square root property. And when did I apply it? When the equation was missing the first power term. The x to the first power term was gone. That equation lends itself beautifully to this square root property method for solving.